Hello viewers, this is Josephine. You're welcome to the channel. Today we are going to look at conversion of a galvanometer to an ammeter. A galvanometer is a device used for measuring small electric current, okay? But an ammeter is used for measuring current. Now this galvanometer is measured in milliamperes. How can this galvanometer that measures in milliamperes, very minute current, start measuring a whole number? For example, 10 amperes, 5 amperes. Okay, we want to see a situation whereby we can use a galvanometer to measure a high current, knowing fully well that it is made for a very small current. So I want you to watch this video to the end so that you can understand how we can use galvanometer to measure current. So let's look at what we have on the board. We can convert the galvanometer into an ammeter by connecting a suitable resistor in parallel with the galvanometer. So let's underline this parallel because it's very important for JAMB students. A resistor used for this purpose is known as shunt. Okay, shunt. The shunt is a low resistance wire and is used to divert a large part of the current being measured, but to allow only a small current to pass through the galvanometer. Okay, we are trying to say that we can actually use this galvanometer, we can actually convert this galvanometer to ammeter. That is making galvanometer to start doing work of ammeter by using a low resistance wire, which must be connected in parallel. And the name of that low resistance wire is called what? Shunt. What is the purpose of this shunt? Its purpose is to divert a large part of the current being measured and to allow only a small part of the current to pass through the galvanometer. So that is the only way a galvanometer can be made to measure what? Current. So let's use an illustration on the board to explain what we just said. Stay tuned. Looking at this diagram, we will see that this is a galvanometer, okay, that shows a full scale deflection. This is what? The shunt, which is the low resistance wire that must be connected in parallel with the galvanometer. So they are parallel to each other. Alright, there is a current flowing into this particular circuit, okay? The current flowing through this circuit, it will move straight to the galvanometer because current always flows in what? In series. But when you come to this place, there is a bridge here. The current needs to flow to the what? To the shunt. Is that okay? The current needs to flow to the shunt. And for the current to flow to the shunt, we have to subtract the total current flowing through the galvanometer. Then the remaining one will now go to the what? To the shunt. Alright. The first thing we are going to do is to look at the PD. When two resistors are connected in parallel, it means that the PD across galvanometer is equal to the PD across what? The shunt. Is that okay? So we have PD, that is potential difference across galvanometer is equals to PD across shunt. But you know what is PD? From Ohm's law, potential difference is equals to current times resistance. Okay, so I can make reference from Ohm's law. From Ohm's law, V is equal to what? IR. So if we bring it back to what we have, I will just say that the PD, which is V across galvanometer, is equals to the PD across what? Shunt. But what is my PD? I times what? R. Current times what? Resistance. So this will be what? Current flowing through the galvanometer, which is this one, multiplied by the resistance of the galvanometer, which will be given to you, right? Then is equals to current of the shunt multiplied by what? Resistance of the shunt. Is that okay? Now, how do we get the current of the shunt? Because I told you earlier that if the total current flowing is I and this particular one is going into the galvanometer, how will you know the one that is flowing through the shunt? we have to subtract this current of the galvanometer from the total current flowing because of this bridge here, right? So the difference we have is the current flowing through the shunt. Okay, so I can say that current of the shunt is equals to the total current flowing minus current of what? The galvanometer. Is that okay? So we can otherwise say that what? This is Ig Rg is equals to I minus Ig, then bracket what? Rx. Okay, so the purpose of this thing we are explaining is because we're looking for the low resistance wire, which is what? The shunt. So invariably we are making it the subject, so we divide both sides by I minus Ig, I minus Ig. Okay, so it will cancel. The resistance of the shunt is equals to Ig Rg is equals to over, sorry, minus Ig. Is that okay? So let's see how we can use this illustration now to solve for the resistance of the shunt. That is only way we can make this galvanometer that is measured in milliamperes to start measuring what? In amperes. Is that okay? And remember that milliamperes, if I say 1 milliampere is the same thing as saying 1 times 10 raised to power minus 3 amperes, or I can say 0.0011 what? Amperes. So this is how galvanometer measures current. Do you understand? Now we want to see how this one that measures 0.001 amperes to start measuring 1 ampere, which is a whole number. Okay, so I want you to watch this video to the end so that I can understand how to do that. And if you are watching this channel for the first time, thank you for stopping by. Stay tuned. All right, let's look at this example. A galvanometer of resistance 5.0 ohms has a full scale deflection for a current of 100 milliamperes. How would its range be extended to 1.0 amperes, right? Okay, so the first thing we are going to do is to state our parameters and understand what this question is trying to tell us. If we're able to state the parameters and actually know what we are looking for, then we can easily solve our problem. All right, so this galvanometer has a resistance of 5 ohms, so it means that the resistance of galvanometer is 5 ohms and the current is 100 milliamperes. That is, current of the galvanometer is 100 milliamperes. Okay, 100 milliamperes is something as saying 100 times 0.001, right? Then I'll multiply because this milli is 0.001. If I multiply, I'm going to have 0.1 amperes. Okay, so that is the current flowing through the galvanometer. Now, what is the total current flowing? The total current flowing in the circuit is 1 amperes. Now, if you know that the total current flowing through the circuit is 1 amperes, we need to get the current flowing through the shunt, right? So I will say current of the shunt is equals to the total current flowing minus current across what? The galvanometer, right? Now the total current flowing is 1 minus current across the galvanometer is 0.1. Then I'll subtract. I will have 1 minus 0.1 to give me 0.9 what? Amperes. All right. The next thing we are going to do is remember the formula. PD across galvanometer equals to PD across shunt, or we say PD across shunt equals to PD across galvanometer. That is what? Vx is equals to what? Sorry, is equals to Vg, right? What is Vx? Vx is Ix Rx is equals to what? Ig Rg. So my Ix is 0.9 Rx is equals to Ig is 0.1 times, okay, Rg is what? 5. All right, So I'm going to have 0.9 Rx is equals to 0.5. Because I'm looking for the resistance of the shunt, I'll divide both sides by 0.9, 0.9. So this will cancel. Okay, so I have Rx. Okay, this is the same thing as saying 5/9. I hope I'm correct. All right, because this will cancel each other. I have 5/9. So what do I have? 5/9. Then I want to change it in decimal. Is going to be 0.556 what? Ohms. Do you understand it now? Now, this is the only way the galvanometer can be converted to what? Ammeter, right? If you're able to know the total current flow, which is 1 amperes, then you subtract it from the current of the galvanometer. That will give you the current of the shunt, right? You use our PD formula, that's from Ohm's law. PD across shunt equals PD across galvanometer. Then you have stated everything, and make sure you remove this milliamperes, okay? Multiply whatever thing given to you by 0.001, okay? Whatever thing you have becomes the current of what? The galvanometer. So this is how we can make galvanometer that has been already designed to measure in milliamperes to start measuring in amperes. Is that okay? All right, if you're watching this channel for the first time, please give it a thumbs up and subscribe to this channel for more educative videos. I'll put up an assignment and you have to solve it and drop your answer in the comment section. I want you to follow these classes so that you'll be able to know that you can comfortably solve physics without stress. Okay, so the more you solve the assignment, the more you learn physics better. See you next time in my next class. Bye.